Hi, welcome to the Corbettmaths Ultimate CCEA M2 revision video. This video will go through all the M2 only topics, so if you are studying for M2, remember to watch the Ultimate M1 revision video because M2 will include M1 topics and M2 topics. If you're studying for M3, M4 and so on, it's very important to know these M2 topics because they're also going to be included on those papers as well. Okay, a few things about M2. M2 lasts for an hour and 45 minutes. It's a calculator paper, so in this video there will be some topics that are typically non-calculator topics, and I will go through them because it's very important that if you're told to cover that topic, it needs to be taught and you need to make sure you understand it. So it may include non-calculator methods, but in the exam you will have that calculator. Okay. So in this video, I'll be going through the following topics. These are the topics that are mentioned in the specification on M2, and I also studied all the past papers to make sure that all those M2 topics are in here. So you've got all the M2 only topics here. So you've got the red topics, which are the number topics. You've got the orange topics, which are statistics or data handling topics. The topics in green are the geometry or shape, space, measure topics, and the topics in blue are the algebra topics. And this revision checklist is very important. So in the description below, you'll find a link to it. I personally would print it off, save it, include it in your notes to make sure you've got it, and take off the topics as you've gone through it. Beside each topic there's the video number. That will be if you want a more detailed explanation to the topic. So in this video my aim will be to spend 2 or 3 minutes going through each of these topics, but if you want a more detailed explanation to these topics, you will find them by going to corbettmaths.com/content and going to the following video numbers. Also, along with this video, I've made the Ultimate CCEA M2 revision question booklet, catchy title. In that booklet, there are questions on all of these topics, just to make sure that you're familiar with all of these topics. So in this booklet, you'll find questions on all of the topics that are mentioned in the revision checklist. Also, you'll find a QR code to this revision video and to the answers. So if you're doing that practice booklet and you want to check your answers, you can scan the QR code. And if you need some extra help on a particular topic, if you scan it, you'll be brought to this video. Another thing in this video that I go through quite a few of the revision cards. So I've borrowed some of the revision cards and mentioned them within the video. So if you find those revision cards useful, you might want to get yourself a copy, and you can do that on Corbettmaths. And also, whenever you're studying for M2, it's very important that you don't just cram all your revision in at the very end. So I would highly recommend the 5 a days. The idea is spending 5-10 minutes every day doing some maths, and that will really boost your confidence. So for M2, I would be looking at the orange foundation booklets. Okay, let's get started. So our first topic is index notation, and that is video 172 on Corbettmaths. So if I had 5 times 5 times 5, that is 5 cubed, and from the M1 video you'll remember your cube numbers, which is multiplying a number by itself and by itself again. You may want to write it in index notation, which means write it as a number with a power. So we could write that as 5 cubed because there's 3 5s multiplied together. Here we've got 2 times 2 times 2 times 2 times 2 times 2. So writing that in index form, because there's 1, 2, 3, 4, 5, 6 2s, we would write 2 to the power of 6. And if we had y times y times y times y, because there's 4 y's multiplied together, we would say y to the power of 4. It's very important to be able to write these in index form, particularly for a topic called product of primes, and I'll talk about that in a moment. Now, one other thing is, remember M2 is a calculator paper, so if for instance you wanted to work out 2 to the power of 6, because it's a calculator paper, you can use a calculator to help you. So here's a calculator. So what I would do is I'd press the 2 button, so I'd press 2. And then there's the power button, and on my calculator it's an X with a little white square just above it, like so. So I'd press that button, and on your calculator display above the 2 would be a little rectangle or a little box appears. And then press 6, and then press equals, and then you will get the answer. So 2 to the power of 6 is 64. And that's just a quick way of working it out on your calculator rather than writing 2 times 2 times 2 times 2 times 2 times 2. So that's index notation. And as I said, it's very useful for a topic called product of primes. We'll look at that in a wee moment. Okay, let's have a look at our next topic. So our next topic is laws of indices. And there's 3 very important laws of indices that I would recommend you know for M2. And this is video 174 on Corbettmaths. So our first law, well, if you're multiplying things with the same base, so for instance, if you had m cubed multiplied by m to the power of 4, well, that would be m times m times m cubed, multiplied by m times m times m times m, and altogether there'd be 7 of them, so that'd be m to the power of 7. And a quick way to work that out is, because we've got m to the power of 3, and we're multiplying by m to the power of 4, you can add these powers. You can do 3 plus 4 is equal to 7. And this is the Corbettmaths revision card on laws of indices, so if you've got the revision card, this revision card will be very useful for you. Okay, next one, if we're dividing, if you had m to the power of 8, so if you had m times 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 m, and you divided that by m squared, that's m times m, 2 of the m's would cancel out with 2 of the m's, so you'd be left with m times m times m times m times m times m, and that'd be m to the power of 6, which is m to the power of 6. And a quick way to work that out is, if you're dividing and you've got the same bases, you can take away the powers. You can do 8 take away 2, and that's m to the power of 6. And finally, we've got a power of a power, so if you've got a power and then another power, you multiply the powers together. And let's have a look and see why that works. So if you had m cubed squared, remember squared means multiply by itself, so we're doing m cubed multiplied by itself, so that's m times m times m, multiplied by itself, so that's m times m times m, and if you multiply all those together, you'd get m to the power of 6. And a quick way of doing it is to multiply the power. So if you've got a power to a power, you can multiply the two powers. 3 times 2 is equal to 6. So let's have a look at some examples. So if I had 3 to the power of 4 multiplied by 3 squared, I'd add the powers together because it's multiply, and that would be to the power of 6. If I had 3 to the power of 10 divided by 3 squared, I would subtract the powers, so 10 take away 2 is equal to 8. And finally, if I had 4 squared cubed, I would multiply the powers because it's a power of a power. You've got a power and then another power. So you'd multiply the powers together. 2 times 3 is equal to 6, so it would be 4 to the power of 6. And that's it. So there are your laws of indices that will be very important, and as I said, they're very useful for a topic called product of primes, and let's have a look at that topic now. Okay, let's have a look at our next topic. So our next topic is product of primes, and that's video 223 on Corbettmaths. So every single whole number that is greater than 1 is either prime or can be written as a product of primes, and the word product means to multiply, so it either means that every single number that's greater than 1 is either a prime number or is equal to prime numbers multiplied together. So our first question, our example says, write 60 as a product of primes. So it's very important that you know your prime numbers, and your prime numbers are 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, and so on. And it's very important you know those prime numbers. So we're going to write 60 as a product of primes, and we're going to give our answer in index form. So let's start off with 60, and I like to do this using a prime factor tree. You can use another approach by using sort of an upside down bus shelter. Whatever approach you prefer is totally fine, but I like to use a prime factor tree like so. So 60, I think of two numbers that multiply together to give me 60. So I'm going to go for 2 times 30. So 2 times 30 is equal to 60. Now we look and see if either of these numbers are prime, and 2 is prime, so I'm going to circle it, but 30 is not prime. So what I'm going to do is I'm going to think of two numbers that times together to give me 30. So 3 times 10. Now 3 is prime, so I circle it, whereas 10's not. So I'm now going to think of two numbers that multiply together to give me 10, and that's going to be 2 times 5. Never choose 1 in the number itself because you don't get any further. So 10 would be 2 times 5, so 2 times 5, and let's circle them. And that's it, we're finished. So 60 is equal to 2 times 3 times 2 times 5. So let's write that out. 60 is equal to, and let's just do it in order. So instead of doing 2 times 3 times 2 times 5, I'm going to do 2 times 2 times 3 times 5. So 2 times 2 times 3 times 5. And let's just check it works. 2 times 2 is equal to 4, times 3 is equal to 12, times 5 is equal to 60. And as you can see, we've written 60 as a product of primes. But the question says to write it in index form. Now, as you've just seen earlier on with index notation, if you've got something such as 2 times 2, that's 2 squared. So we can write 60 is equal to 2 squared multiplied by 3 multiplied by 5. So we've written 60 as a product of primes in index form. And that's it. And it's very important to be able to do that in M2, and video 223 will go through that. And also, if you go to corbettmaths.com and you go to videos and worksheets and you scroll down to 223, as well as having the video tutorial, there will be some practice questions and textbook exercises on this topic. So if you do want extra practice, feel free to do those. But also remember, there's the M2 revision booklet, which you can print. It's the links in the description below. And if you have that, there's some questions on this now. Okay, let's have a look at our next topic. So our next topic is applying product of primes, and that's video 223A in Corbettmaths. So let's start off by looking at this question. So a number m has been written as a product of primes as 2 multiplied by 3 squared. So this is m, 2 multiplied by 3 squared, and the first part A is to say what number is m. So let's work this out. Now remember, from M1 we've got our order of operations. That is, we do any brackets? No. Orders, now that's another name for powers, so that's squared, so we're going to work out the squared first of all. So we're going to do 3 squared, so 3 squared is 9, and then we're going to multiply by the 2. 2 times 9 is equal to 18. So that means m is equal to 18. Remember, M2 is a calculator paper, so you could just type that into the calculator because the calculator will work out the order of operations for you. And part B says, write the number 10m as a product of primes. So 10m, well, if we know that m is equal to 18, 10m would be equal to 10 times m, so that would be 180. So you could take 180 and do that prime factor tree and find out what 180 is as a product of primes. Now what's really useful here is we know that 10 is equal to 2 times 5. So two prime numbers, 2 and 5, multiplied together would give me 10, 2 times 5. Now we know that m is equal to 2 times 3 squared. So m is equal to 2 times 3 squared. So if we multiply this 10 by m, which is 2 times 3 squared, that would be our answer. But we want to write this obviously in index form. And as you can see, we've got 2 times 5 times 2 times 3 squared. I would look at the 2's first of all. You've got 2 times 2, which is 2 squared. We've then got our 3 squared, so multiply by 3 squared, and then multiply by 5. So 2 squared times 3 squared times 5 would be 10m. And we can check that, because remember we knew that 10 times m was 180. Let's check this as 180. 2 squared is 4, 3 squared is 9, 4 times 9 is 36, and multiplied by 5 would be 180. So that means that 10m as a product of primes would be 2 squared times 3 squared times 5. Okay, our next part. Now we can also use product of primes to find square numbers and cube numbers. So for instance, if we knew that 280 was 2 cubed multiplied by 5 multiplied by 7, and we were asked what the lowest whole number that 280 would need to be multiplied by to give a square number, what we can do is we can consider what a square number is. So a square number is a number multiplied by itself, and that would give you a square number. So if we take what we've been given here, so 280 is 2 cubed, that's 2 times 2 times 2 times 5 times 7, just writing it out in full. If we share these prime numbers out as evenly as possible, and then find out what extra ones we need, then we can find out what number you can multiply 280 by to get a square number. So let's share these numbers out as evenly as we can. So we've got 2, 2, 2, that's 3 2's. So we're going to have to give one circle 2 2's and one circle 1 2. We've got a 5. Well, unfortunately, that's just going to have to go in one of the circles as well. We can't, we don't have 2 5's. And we've got a 7. So again, that's going to have to go in one of the circles. Now we want the same thing in both of these circles. So let's put some extra prime numbers in this circle. So we had 2 2's. So we're going to need another 2. We're going to need a 5. And we're going to need a 7. If we multiply 280 by 2, 5 and 7, that should give us a square number. So let's see what 2 times 5 times 7 is. So 2 times 5 times 7 is equal to, well, 2 times 5 is 10, times 7 is 70. So if we multiply 280 by 70, we should get a square number. So 280 multiplied by 70 is equal to 19,600. And if we work out the square root of that, we get that's equal to 140. So it is a square number. So if you want to find a square number, what you need to do is share out the prime numbers that you've been given as evenly as possible, and then add in the extra ones you need. And there is a bit of a shortcut. If we take all the numbers in the circles here, are 2 times 2 times 5 times 7 times 2 times 2 times 5 times 7, that would be 2 times 2 times 2 times 2, which is 2 to the power of 4, times by, and we've got 5 times 5, that's 5 squared, and we've got 7 times 7, that's 7 squared. If you notice, all the powers are even. So if you want a square number, all you'd need to do is to make all the powers even. So if I was doing this question, I would first of all just look and see, well, it's 2 cubed, well, I'm going to need an extra 2. I've got 5, well, that's 5 to the power of 1, so I need an extra 5. And I've got 7 to the power of 1, so I need an extra 7. So if I multiply this by 2 and by 5 and by 7, I will get a square number. And likewise, if I wanted to find a cube number, all the powers would have to be multiples of 3. So for instance, if I had 2 to the power of 9 multiplied by 5 to the power of 3, that would be a cube number because this power is a multiple of 3 and this power is a multiple of 3. Okay, let's have a look at our next topic. Our next topic is called LCM, or lowest common multiple, and that's video 218 and 219 on Corbettmaths. So in M2, to find the lowest common multiple of two numbers, you consider their multiples. So if we had 6, the multiples of 6 would be 6, 12, 18, 24, 30, 36, and so on. The multiples of 15 would be 15, 30, 45, and so on. And the lowest common multiple, or the LCM, is the first number in both of those lists. And as you can see, 30 is the lowest common multiple. It's the first number in both the multiples of 6 and the multiples of 15. So 30 is the lowest common multiple, and that's it. Okay, our next topic. Our next topic is finding the highest common factor, and again in M2 we're going to do this by considering the factors and finding the highest common factor. And again, videos 218 and 219 will go through the HCF, highest common factor, and the LCM. So let's have a look at the highest common factor. So let's consider 16. So 16 is equal to 1 times 16, 2 times 8, and 4 times 4. So the factors of 16 are 1, 2, 4, 8, and 16. And if we consider 20, well, 20 is equal to 1 times 20, 2 times 10, and 4 times 5. So the factors of 20 are 1, 2, 4, 5, 10, and 20. And let's look at our common factors. Our common factors are 1, 2, and 4. So they are our common factors. And the highest common factor, well, that's going to be 4. So the highest common factor of 16 and 20 is 4. And this topic is particularly useful if you want to cancel fractions and factorize and things like that. Okay, our next topic. Our next topic is arithmetic with decimals. And when we move from M1 to M2, the arithmetic with decimals just gets a bit trickier. It's just, it says, you might need to go past 3 decimal places and things like that. So let's do some arithmetic with decimals. So it's the same techniques, it's just the numbers are a bit larger. So we've got 4.2535 add 1.268. So just lining up the numbers and then put a line beneath it and our add sign. And as you can see, we've got 4.2535, so that's got 4 decimal places, and 1.268 has only got 3 decimal places. So let's put a 0 there, and let's add up our numbers. So we've got 5 plus 0, that's 5. 3 plus 8, that's 11, so put 1 down and carry a 1. 5 plus 6 is 11, plus 1 is 12, so put the 2 down and carry the 1. 2 plus 2 is 4, plus 1 is 5, and 4 plus 1 is equal to 5. So 4.2535 plus 1.268 would be equal to 5.5215, and that's it. Okay, our next topic is subtracting decimals. So we've got 5.2 subtract 1.9574, and again let's put our zeros in so they're the same length and put our line beneath it and our decimal point and our takeaway sign. Okay, so we've got 0 takeaway 4, but we can't do, so we're going to borrow. We can't borrow from there, we can't borrow from there, so we're going to need to borrow from the 2, call that a 1, and now this is 10. Borrow from the 10, that's a 9, and now this is 10. Borrow from the 10, that's a 9, and now this is 10. So we've got 10 takeaway 4, that's 6. 9 takeaway 7, that's 2. 9 takeaway 5, that's 4. 1 takeaway 9, well, we're going to have to borrow again, so it's 4 and 11. 11 takeaway 9, that's 2. And 4 takeaway 1 is 3. So the answer would be 3.2426. That's it. And if you want more practice on arithmetic with decimals, that's videos 90 to 94 on Corbettmaths. So we've now got multiplying decimals and dividing decimals. So multiplying decimals. Now, to multiply decimals, we can do this in 2 ways. We can either just ignore the decimal point and do 2,854 and multiply that by 8. And then looking at our question, we've got 1, 2, 3, 4 numbers after the decimal point. So you put the decimal point in the answer, so there's 4 numbers after it. Alternatively, you could multiply this number by 1,000 to get 2,854, and you can multiply this number by 10 to get 8, and then with your final answer you divide it by 1,000 and divide it by 10, and then that would give you your answer as well. Okay, so let's do 2,854 multiplied by 8 and see what we get. So 8 times 4 is equal to 32, so put the 2 down and carry the 3. 8 times 5 is 40, plus 3 is 43, so put the 3 down and carry the 4. 8 times 8, 64, plus 4, 68, so put the 8 down, carry the 6. And 8 times 2 is equal to 16, plus 6 is 22. So we've got 22,832. And to get our final answer, we can either consider the decimal places in the question. So it was 1, 2, 3, 4 numbers after the decimal points in the question. So it's going to be 4 after it in the answer. So the answer will be 2.2832, like so. Alternatively, you can take this 22,832 divided by 1,000, because you need to multiply this number by 1,000 to get a whole number. So dividing this by 1,000 would be 22.832, and then dividing it by another 10 would be 2.2832, and that's it. Okay, and our next question is dividing by decimals. So we've got 12 divided by 0.04. Now remember that if you have something like 6 divided by 3, that's equal to 2. And if you multiply both those numbers, the number you're dividing and the number you're dividing by, both by 10, you get 60 divided by 30. And whenever you divide that, you get 2. And if you had 600 divided by 300, you get 2, and so on. So as long as you multiply both the number you're dividing and the number you're dividing by either 10 or 100 or 1,000 or whatever, you'll always get the same answer. So if we had 1.2 divided by 0.04, I want to turn this 0.04 into a whole number. So I want to multiply it by 10 and by 10 again to get 4. So I want to multiply it by 100. So I'm going to multiply both these numbers by 100. So 1.2 times 100 is 120, and 0.04 times by 100 is equal to 4. So we're going to do 120 divided by 4, and that's equal to 30. So the answer would be 30. Okay, let's have a look at our next topic, and our next topic is rounding, which is video 279A in Corporate Maths. Now in M1, we have to round to one significant figure. In M2, we may have to round beyond that, so maybe 2 or 3 significant figures. So let's round these numbers to 2 significant figures. So if I wanted to round 394 to 2 significant figures, I'm going to look at the first 2 digits, the 3 and the 9, and I'm going to make all the digits after the 9 zeros. So I could either round this to 390 or 400, because then that would make this a 0. Now, because this is 4, we're going to round down, so 394 rounded to 2 significant figures would be 390. Next, we've got 1,273, and we're going to round it to 2 significant figures, so we're going to have the 1 and something, and then zeros. Now here I've got a choice of either 1,200 or 1,300. Because it's 73, I'm going to round up, so it's going to be 1,300. Next, I've got 7,961, and I want to round it to 2 significant figures, so I'm going to want to have 2 digits at the front followed by zeros. Now I've got a choice here. It could either be 7,900 or going up would be 8,000, where it was 80 and then followed by zeros. Because this is 6, we're going to round up, so that means we're going to round up to 8,000. So our answer would be 8,000. Next, we've got 0.618, and we want to round it to 2 significant figures. Now we ignore this 0 point at the front, so we've got our 6 and 1 being the 2 significant figures. So our choice is going to be 0.61 or 0.62. Because it's an 8, we're going to round up, so we're going to write it as 0.62. And finally, we've got 20.501, and we want 2 significant figures. Now, because we've got the 2 at the front, this 0 is significant, so we're either going to have 20 or 21. Because it's 20.5, we're going to round up, so our answer would be 21. And that's it. So we've rounded these numbers to 2 significant figures. And if you want more practice, video 279A in Corporate Maths, we'll go through that. Okay, our next topic. Our next topic is recurring decimals. And in M1, you would have seen lots of terminating decimals. For instance, a half is 0.5, it stops. Or a quarter is 0.25, and there it stops. A recurring decimal is where the decimal goes on forever. Now, in M1, if you looked at the key fractions, decimals, and percentages, you may have noticed that 1/3 was written as 0.3333 and so on. It goes on forever. And if you do it in your calculator, 1 divided by 3, you will get 0.333333 and so on. And the calculator display will just carry on with 3s. Now sometimes, if you do it in your calculator, you will see this 0.3 with a little dot above it. And that means that the 3 carries on. So that means that if you see this little dot, it means that it is recurring and it just carries on forever. So if, for instance, we had 2/3, if you've done 2 divided by 3 on your calculator, you will get 0.6666 and so on. Alternatively, it could be written as 0.6 with a little dot above it. And again, that just says that the 6 carries on. Okay, our next question says to write 2/9 as a decimal. So we would do 2 divided by 9, and if we do 2 divided by 9 on our calculator, we get that's equal to 0.22222 and so on. Alternatively, it can be written as 0.2 with a little dot above it, and that just means it carries on forever. Finally, if we were asked to write 5/11 as a decimal, we would do 5 divided by 11, so 5 divided by 11, and we get that's equal to 0.454545 and so on, and that pattern just carries on with 4545 just carrying on. And using the little dot, we would write 0.45 and with a dot above the 4 and above the 5, and that would just mean that the 4 5s carry on, so it's 0.454545, and it has a dot above both of them. And that's it. Our next topic is adding fractions, and that's video 133 on Corporate Maths. So to add fractions, it's very important that the fractions have the same denominator, a common denominator. So for instance, if we were asked to work out 2/5 plus a quarter, as you can see, the denominators, the numbers on the bottom of the fraction, aren't the same. We've got a 5 and a 4. So what we're going to do is we're going to find the lowest common multiple of 5 and 4. Well, that's going to be 20, because 5, 10, 15, 20, 4, 8, 12, 16, 20. The lowest common multiple of both of them is 20. And what we're going to do is we're going to find 2 equivalent fractions. Now remember, to find an equivalent fraction, we consider what do you multiply 5 by to get to 20? Well, that's 4. So you multiply the numerator by 4 as well. So 4 times 2 is equal to 8. So 2/5 is the same as 8/20. Next, our quarter, we want to have 20 on the denominator. So to get from 4 to 20, you multiply by 5. So you need to multiply the 1 by 5 as well. So that's going to be 5. So 1/4 is 5/20. And finally, we've got 8/20 plus 5/20. When we're adding fractions with the same denominator, we just add the numerators. So if we had 8/20 plus 5/20, that's going to be 13/20. 20ths, and that's it. So 2/5 plus 1/4 is 13/20. Okay, let's have a look at our next question. So our next question is to work out 2 7/9 plus 1 2/3. So here we've got some mixed numbers, and the mixed numbers where you've got a whole number and a fraction. So for instance, 4.5. And we're going to be dealing with these mixed numbers. And whenever we're dealing with mixed numbers, whenever we're adding or subtracting or multiplying, dividing fractions, it can be very useful to turn them into top-heavy fractions. And that's where we write them as a fraction with a larger number on the numerator than on the denominator. And to do that, well, we just consider 2, and we're dealing in ninths here. So if I had a cake or a pizza and I cut it into ninths, there'd be 9/9 in a pizza. In 2 pizzas, there would be 18 slices. You would have 18 ninths. So 2 is equal to 18 ninths. And then we've got another 7/9. So if I had 18 ninths and another 7/9, that would be 18 plus 7 is 25 ninths. Now the shortcut I take with this is I just multiply the whole number by the denominator. So 2 times 9 is 18. And add on the 7 is 25. So if I just take the whole number, which is 2, and times it by the denominator, so 2 times 9 is 18, and add on the 7 is 25. So that gives me the 25 ninths. Next, I take the whole number, which is 1, and I do 1 times 3 is 3, and add on the numerator, which is 2, so 3 plus 2 is equal to 5, so it would be 5/3. And again, let's just check this. If I had a pizza and I cut it into thirds, that's 3 slices, and another 2 slices is 5 slices. So here we've written our mixed numbers as top-heavy fractions. So we want to have the same denominators. So we've got ninths and we've got thirds. So the lowest common multiple of 9 and 3 would just be 9. We could multiply both the numerator and the denominator of this fraction by 3, and that would give us 9 on the denominator. So let's do that. So we've got 25 ninths, and then we're going to add, if we multiply both of these by 3, we get, well, 5 times 3 is 15, and 3 times 3 is equal to 9. So we've got 25 ninths plus 15 ninths, and that's fantastic because they've both got the same denominator. So if we just add the numerators, 25 plus 15 is 40, so our answer would be 40 ninths. Now if the question's in mixed numbers, such as 2 and 7/9, I would change this top-heavy fraction or answer into a mixed number as well. Remember, the line in a fraction means divided by. So how many 9s go into 40? Well, 4 9s is equal to 36, so it's going to be 4. And 36, well, we have 40, so our remainder would be 4. So our answer would be 4 and 4/9, and that's it. Our next topic is now subtracting fractions, and that's the same technique. We get a common denominator, and then we just take away the top numbers. We take away the numerators instead. So if we had 9/10 and 2/3, so if you look at the denominators, we've got 10 and 3. Now the first number in the 10 times tables and 3 times tables would be 30. So I'm going to write a common denominator of 30. So if I multiply both of the numerator and denominator of this fraction by 3, well, 10 times 3 is 30, and 9 times 3 is 27. And with this fraction, we had 2/3. If we multiply the 3 by 10, we get 30. And if we multiply the 2 by 10, we get 20. So we've got 27/30, take away 20/30. Well, if you had 27/30 and you took away 20/30, you're left with 7/30, just taking away the numerators. And that's it. Okay, our next topic. Our next topic is multiplying fractions. So multiplying fractions is really easy. You just need to multiply the numerators and multiply the denominators, and that's it. So if you had 2/5 times 1/4, if you multiply the numerators, 2 times 1, that's 2. And if you multiply the denominators, 5 times 4, that's 20. Now the answer here is 2/20. I'm going to cancel this down. I'm going to simplify it. We can divide both of these by 2. So our final answer would be 1/10. Okay, next we've got 1 and 1/7 multiplied by 2/3. Again, this is a mixed number, so let's make this a top-heavy fraction. 1 times 7 is 7, plus the 1 is 8, so 1 and 1/7 would be 8/7. Or another way to think of it is if you had a pizza and you cut it into 7 slices, and then you had an extra one, that's going to be 8 slices, so that's 8/7. And then multiply by 2/3. So let's multiply the numerators, so 8 times 2 is 16, and 7 times 3 is 21. So our answer would be 16 over 21. 16 and 21 have no common factors apart from 1, and that's not going to help us. So if you want more practice on multiplying fractions, if you watch video 142 on Corbettmaths, you can watch the video tutorial on it, you can do some practice questions, do the textbook exercises, but also remember you've got that M2 practice question booklet, so you can do these questions down that booklet and just make sure you're happy with this topic. Okay, let's have a look at our next topic. Our next topic is dividing fractions, which is video 134 in Corbettmaths. So to divide fractions, what we do is we multiply by the reciprocal of the number we're dividing by. And that sounds really complicated, but what it means is if you've got 7/15 divided by 3/4, instead of doing 7/15 divided by 3/4, what we can do is we can do 7/15 multiply by, and then we can find the reciprocal of 3/4. And the reciprocal is a fancy word for flipping it over. So instead of writing 3/4, we could write 4/3. Okay, so we've got 7/15 multiplied by 4/3. Now we've got multiply, so we can just multiply the numerators and multiply the denominators. So 7 times 4 is equal to 28, and 15 times 3 is equal to 45. So answer is 28/45. And apart from 1, they've got no other common factors. So that's it. So if you watch video 134, that'll be quite a useful video to see why this works. But in this video, I'm just trying to make sure that you're familiar with each of these topics. So to divide fractions, what we do is, instead of dividing by 3/4, we multiply by its reciprocal. So we change the divide to multiply, and you find the reciprocal of the second number. And then you just multiply the fractions, and that will give you the answer. Okay, our next question. Our next question is to work out 2.5 divided by 1 3/5. So we've got mixed numbers here, so let's turn them into top-heavy fractions. So 2, well, we've got 2 times 2 is 4, plus 1 is 5, so it's going to be 5 halves. And another way to think about it, remember, is if we're dealing with halves, if you had 2 pizzas and cut them into halves, you've got 4 of them, and another one would be 5 of them, so that'd be 5 halves. And we're dividing by, well, if we look, we've got 1 3/5, so 1 times 5 is 5, plus 3 is 8, so it's going to be 8/5. Now remember, we want to multiply by the reciprocal of the number we're dividing by, so we're going to write 5/2 multiplied by 5/8. Next, we're going to multiply, so we've got 5 times 5 is 25, and 2 times 8 is 16. So our answer would be 25/16. Now because the question is given in mixed numbers, I'm going to write this top-heavy fraction as a mixed number. So the line means divide by, so we've got 25 divided by 16. So there's 1 16 in 25, and the remainder is 9, so we've got 1 and 9/16, and that's it. And just before we move on to our next topic, it's very useful to remember that M2 is a calculator paper. So it's important to know where the fraction button is on your calculator. So here's my calculator, and as you can see here, I've got this box, this white box, a line, and then a hollow box beneath it. That is the fraction button there. So if you press that on your calculator, you will get the fraction button. And if you do need to type a mixed number into your calculator, then you can look just above it in yellow, and you've got this mixed number button. So you'd press Shift, and then you'd press the fraction button, and then the mixed number display would come up in your calculator. So that can be very useful for M2 because remember, it is a calculator paper. Okay, so our next topic is percentage change, and this is video 233 in Corbettmaths. So percentage change is calculated by change divided by original times 100. Sometimes in a question you might be asked to find the percentage increase, percentage decrease, percentage profit or percentage loss, and they'll all be calculated the same way by using this formula. So here's a typical question. It says the height of a plant increases from 30 centimeters to 46 centimeters. Work out the percentage increase. So the formula is change. So as you can see, the change is 16 centimeters, so change is 16, divided by the original, which would be 30, and then times by 100. So if we do 16 divided by 30 times 100, we get that's equal to 53.333 and so on percent. So the percentage increase would be 53.333 so on percent. Or we could round this. Sometimes in the question you're asked to give your answer to 1 or 2 decimal places. So let's round this to 2 decimal places. So the answer would be 53.33%. And that's it. So percentage change is change divided by original times 100. Okay, our next topic. Right, so our next topic is compound interest, and that's video 236 on Corbettmaths. So compound interest is where the interest is added at the end of every single year. So our question says, James invested £8,000 in the bank for 2 years, and it earns compound interest at a rate of 5% per year. Calculate the total amount of money that James has in the bank at the end of 2 years. Now there's 2 different ways to do this question, and I'm going to show you both approaches now. The first approach is to just treat it like a percentages question. So we're going to increase it by 5% to see how much James has at the end of the first year, and then to work out another 5% of that and add that on to see what he has at the end of 2 years. So at the beginning he has £8,000, and let's work out 5% of that. So let's divide that by 100 and times by 5. So when we divide by 100, we get that's equal to 80. And if we do 80 multiplied by 5, because it's 5%, that gives us £400. So 5% of £8,000 is £400. Now if we add that on, that's how much money James has at the end of the first year. So at the end of the first year, James would have 8,000 plus 400, that's £8,400. Now to see how much money James has at the end of the second year, we now need to work out 5% of this and add it on to find out what he has at the end of the second year. So if we take our £8,400, because that's how much he has, divide that by 100, we get that's equal to £84. And then if we take our £84 and we times that by 5, we get 5%. So 84 multiplied by 5 is equal to £420. So in his second year, James earns more interest. He earns £420. And if we add that on to the 8,400, we'll see how much money James has in the bank account at the end of 2 years. So 8,400 plus 420 is equal to £8,820. So at the end of 2 years, James has £8,820 in the bank. So that's one approach, and that's quite a useful approach for a small number of years, maybe 2 years. But as we go into 3 years, 4 years, 5 years, it can get quite time consuming to do it that way. So there's a quicker way to do that. And to do that, I'm going to show you another topic called multipliers and then come back to compound interest. So we're going to look at multipliers, which is video 239 in Corbettmaths. Now, in M1, we looked at increasing by a percentage and decreasing by a percentage. Now, we can use a thing called a multiplier to do that really quickly and easily. So if we were asked to increase 500 by 8%, we can use a multiplier. Now, if we start off with 100% and we increase by 8%, we'll have 108%. And 108% is the same as 1.08 as a decimal number. So that would be our multiplier. So if we increase by 8%, we'll have 108%, and that's 1.08. So if we take our number, 500, and we multiply by 1.08, that will tell us our answer straight away. It will increase 500 by 8%. So that would be, if we do 500 multiplied by 1.08, that gives us 540. So if we increase 500 by 8%, the answer would be 540. So we can use this multiplier really quickly and easily to do it. So next one, if we wanted to increase 3,500 by 13%, well, the multiplier, well, if we had 100% and we increase by 13%, that's 113%. So our multiplier is 1.13. That's an increase of 13%. So if we take our 3,500 and multiply by 1.13, we get our answer. So 3,500 multiplied by 1.13 is equal to 3,955. So these multipliers are really great for increasing by percentage really quickly and easily, and that'll be useful for compound interest. Likewise, we can decrease using a multiplier. If we decrease something by 2%, we're left with 98% because we would have started with 100%, and decreasing by 2% leaves us with 98%. So as a multiplier, 98% is the same as 0.98, converting the percentage to a decimal. So we can just multiply 3,000 by 0.98, and that would tell us our answer right away. So 3,000 multiplied by 0.98 is equal to 2,940. So you can use a multiplier to decrease by a percentage as well. So if we wanted to decrease 8,000 by 24%, we would take our 8,000 and we would multiply by, well, we would have started off with 100%. We're decreasing by 24%, so 100 take away 24 is 76. So our multiplier would be 0.76. And if we multiply those, we'll get our answer straight away. So 8,000 multiplied by 0.76 is equal to 6,080. And that's it. So this topic of multipliers will be really useful whenever we're looking at compound interest, because if we go back to our question, we had James invested £8,000 in the bank account for 2 years. It earned compound interest of 5% per year. So 5% increase would be 1.05 as a multiplier because it's gone from 100% to 105%. So we can use this multiplier really quickly and easily to work out our answer. So if we want to work out how much money James had in the bank account after 1 year, we could take the 8,000 and multiply by 1.05. If we wanted to work out how much money he had at the end of 2 years, we could then times by another 1.05, and that would tell us how much money he has in the bank after 2 years. Or a really quick and easy way to do it is to do 8,000 multiplied by, because we're multiplying by 1.05 and multiplying by 1.05, we could write 1.05 squared using that index notation. So we could do 8,000 multiplied by 1.05 squared, and let's see what we get. So 8,000 multiplied by 1.05 squared equals 8,820, and that's the same answer as before. So this is really quick and easy way of doing compound interest questions, and it's got a formula. It's the initial, so the amount of money or whatever started with, multiplied by the multiplier to the power of time. So this formula will help us work out compound interest questions really easily. So our initial is the amount of money that was invested to begin with, the 8,000. Our multiplier, because it's a 5% increase, we used 1.05, so that's the multiplier. And because it was 2 years, so we used squared. If it was 3 years, we'd use cubed. If it was 4 years, we'd use to the power of 4, and so on. And that's it. Okay, let's have a look at another question now. So here we've got a finance question, and And you'll see lots of videos on corporate maths under finance. So if you go to video 400, there's 400A, B, C, and so on. And there's lots of different finance topics there that will be useful for M2. So here's a typical question. It says the value of a car decreases by 5% each year. And so if you bought a car 2 years ago for £10,000, work out the value now. So we can use the same formula, initial multiplied by the multiplier to the power of time. So initially the car cost £10,000. And then the multiplier, well, it's decreasing by 5% each year. So if we had 100% and we took away 5%, we'd be left with 95%. So that's 0.95. And we're wanting to find the value of the car after 2 years. So that's going to be to the power of 2. So we do 10,000 multiplied by 0.95 squared. And that gives us £9,025. So the value of the car after 2 years would be £9,025. And that's it. Okay, let's have a look at our next topic. So we're now going to go into our geometry or shape, space and measures topic, and our first topic is density. So we've got this compound measures topic of density, and that's video 384 on corporate maths. So density is calculated by mass divided by volume. So if we take the mass of an object and divide it by its volume, we'll find its density. Now in M1, for speed, distance, time, we use the triangle. You can use the triangle for density as well if you wished. So if, for instance, we wanted to work out density, so we've got density, mass, and volume. So if you covered up the D, you've got mass divided by volume. So density is equal to mass divided by volume. If we wanted to work out the volume of an object, we could cover up the V and do mass divided by density. And if we wanted to find the mass of an object, you could cover up the M and do density times by volume. So I personally like to use this triangle, but if you prefer just to use the formula density is mass divided by volume and rearrange that, that's up to you. So here's our first example. It says a piece of metal has a volume of 50 centimeters cubed and a mass of 900 grams. Calculate the density of the metal. So density is equal to mass divided by volume. And the mass of the object is 900 grams, so we've got 900. And we're going to divide that by its volume, which is 50. So we're going to do 900 divided by 50, and that's equal to 18. So in terms of our units, we were dividing the mass, which is grams, so grams, and we're dividing that by, so per centimeter cubed, so centimeter cubed. And they're quite common units for density. So density, you could measure in grams per centimeter cubed. You can measure in other things like kilograms per meter cubed, but obviously make sure you're looking at the question and seeing what units you use them for. And that's it. So the density of the metal would be 18 grams per centimeter cubed. So that means every centimeter cubed of this metal has a mass of 18 grams. Okay, let's have a look at our next question. This time we're going to work out the volume. So volume is mass divided by density. So it says a glass paperweight has a mass of 400 grams. And it says the density of glass used is 2.5 grams per centimeter cubed. Work out the volume or find the volume of the paperweight. So we're trying to find volume, so it's going to be volume equals mass. So the mass here is 420, and we're going to divide that by the volume, which is 2.5. And when we do that, we get 420 divided by 2.5 is equal to 168. And in terms of our units, it's volume and it's centimeters cubed, so it's centimeters cubed. So the volume of the paperweight is 168 centimeters cubed. And our next question, density. This time we're going to find the mass of an object. So the mass, if we cover up the M, density times volume. Or you could rearrange it if you wish and get mass as density times volume. So Kylie's got a solid glass cube, and the length of each side of the cube is 3 centimeters. And the density of the glass used is 2.5 grams per centimeter cubed. Find the mass of the cube. So we're doing mass is equal to the density times volume. Now the density in the question is 2.5, so that's straightforward, but we're going to multiply by the volume. Now in this question it didn't actually tell us the volume, but we've been told it's a cube. And we've been told that the length of each side of the cube is 3 centimeters. So we need to find the volume of a cube. Now to find the volume of the cube, you're going to do the length times the width times the height. So the volume is equal to length times the width times height. And because it's a cube, they're all the same. So it's going to be 3 times 3 times 3. And 3 times 3 is 9, times 3 is 27. So the volume of this cube is 27 centimeters cubed. So we're going to do 2.5 times the volume, which is 27, and that will tell us the mass. So 2.5 times 27 is equal to 67.5. And in terms of the units, well, we're dealing in grams, so it's going to be grams, and that's it. Okay, our next topic is the perimeter of a semicircle. Now, in M2, well, we've looked in M1 at circumference and area. In M2, you could be asked to find the perimeter of a semicircle. It could even be the perimeter of a quarter circle or a third of a circle. It's going to be a fraction of that full circle, and you could be asked to find the perimeter or the area of it. Let's start off with finding the perimeter of this semicircle, and that's video 243 in corporate maths. So here we've got a semicircle. You can see it's got a radius, the distance from the center of the circle, if it was a full circle, to the edge is 3 centimeters. So the whole way across would be 6 centimeters. And we've got this arc at the top, and we want to find this distance from here around to here, and that will be half of a full circle because it's a semicircle. So if I treat this as a full circle to begin with, and I do pi times diameter, I get the circumference of the whole circle. And then if we half it, and you'll get just this distance here, just the length of this arc at the top. So we can then do 6 plus whatever that is. So we're going to need to use the circumference formula. So that circumference is equal to pi times diameter. So we're going to do pi on our calculator times by the diameter of the circle. And the diameter is 6 here, the whole way across. So we're going to do pi times 6. That's equal to 18.8495592 and so on. And it's important not to round this because we're going to be doing more calculations with this. So you may just want to keep it on your calculator display so then we can do the next stage. So whenever you do pi times 6 and press equals, keep that on your calculator display. So that's the circumference of the whole circle. Now we're dealing with a semicircle, which is half of a circle. So if we take that 18.849 and so on, I'm just going to do some dots so that I don't have to write the whole thing down. And if I divide that by 2, so on my calculator, I've already got that on my calculator. If I press divided by 2, so it comes up with answer ANS divided by 2 on my display, and press equals, I get, it says 3 pi to begin with, and then I press the SD button, and that gives me 9.424777961 and so on. So that 9.424 so on centimeters would be the distance from here all the way around the semicircle to here. So that distance from here around to here would be 9.42477 and so on centimeters. Now we want to find the perimeter of this semicircle, so that's going to be the length of all the sides. So we've got the base and this arc, so we're going to do 9.42477 and so on, and just keep it on your calculator display, plus, and we've got the base. Now the base of the shape is 6 centimeters. We've got our 3 and another 3, so plus 6 gives us 15.42477 and so on. Now I'm going to round this to 2 decimal places. So whenever I round this to 2 decimal places, that would give me 15.42 centimeters. Now it's perimeter, and we're dealing in centimeters, so our units were centimeters, and that's why I use centimeters, and that's it. So to find the perimeter of a semicircle, what you do is you find the circumference of the whole circle and then divide it by 2 to find the length of the arc, and then add on the base. This time we've got this quarter circle, and we're going to find the perimeter of this quarter circle. So what we're going to do is we're going to find the circumference of the whole circle, then we'll divide it by 4 to find the length of this arc, and then we'll add on our 2 sides. So in terms of the whole circle, the circumference of a circle is pi times diameter. Now the diameter of this whole circle will be 30 centimeters because this is the center. So from the center to the edge is 15, so the whole circle will be 30 across. So we're going to do pi times 30, and when we do that we get, that's equal to 94.2477 and so on centimeters. Now that's the circumference of the whole circle, and this is a quarter circle because we can see it's got a right angle, so that's a quarter circle. So we're going to do 94.2477 and so on, and we're going to divide that by 4. And again, I would keep that on my calculator display so I don't have to type it all in again. So divided by 4 gives me 23.5619 and so on centimeters. So that means the length of this arc from here around to here would be 23.5619 and so on centimeters. Now we want to find the perimeter of this quarter circle. So we've got our radius of 15. This is another radius of 15, and then we've got the arc. So we're going to do 15 plus 23.5619 and so on. Now that's already in my calculator display, so I'm going to just press plus 15 equals, and that gives me 53.562 centimeters to 3 decimal places, and I've just rounded that. And you are allowed to round, but just keep it to the very last step. Okay, and that's it. So that's it. So we've looked at the perimeter of a semicircle and a quarter circle. Now sometimes you may need to work out the perimeter of other sectors. So let's have a look at some angles and what they would be. So we've looked at a semicircle. So if it's a straight line, that 180 degrees, that's a semicircle or half of a circle. If there's 120 degrees, that's a third of a circle because 120 plus 120 plus 120 is 360. So that's a third of a circle. So if it looks something like this, that's a really bad sketch, but if that was 120 degrees in there, that would be a third of a circle. So you do pi times diameter to get the whole circumference, divided by 3, and that would tell you that distance, and then add on the 2 straight sides. If it was 90 degrees, like we've just seen, that's a quarter circle. If it's 72 degrees, that's one to look out for. That's a fifth of a circle because 5 72s is 360. If it was 60 degrees, that's a sixth of a circle, because 6/60 is 360. Another one to look out for would be 36 degrees. That's a tenth of a circle, and so on. So in M2, if you've got an angle and you're not sure if it's what fraction of a circle it is, you could just write it as a fraction. So for instance, 120 over 360, and cancel that down, and it will cancel down to what fraction of the circle it is. And that's it. Okay, so let's have a look at finding the area of a semicircle. So that's video number 47 on Corbettmaths. So here we've got a semicircle, and using a similar approach to finding the perimeter of a semicircle, we're going to consider the whole circle. So here's a whole circle. Yeah, there we go. So there's a full circle, and you can see the radius of the whole circle is 3 centimeters. So what we're going to do is we're going to find the area of the whole circle and then divide it by 2. So we're going to do pi times 3 squared, because that will give us the area of the whole circle. And when we do that, we get 28.27433, so on. And then what we're going to do is we're going to divide the area of the whole circle by 2. So we'll take our 28.27433, so on, and we'll divide that by 2, and we find that that's equal to 14.137166, so on, or 14.1 to 1 decimal place. So that's it. So to find the area of a semicircle, you get the area of the whole circle and divide it by 2. So now let's find the area of a quarter circle. So again, let's turn this into a full circle. And as you can see, we've got a full circle, and the radius of the full circle is 15 centimeters. So we're going to do pi times 15 squared to get the area of the whole circle. And that's equal to 706.8583471. Now, because this is a quarter circle, we're going to divide it by 4. So let's take our 706.858 and so on, and divide by 4. And that's equal to 176.7145 and so on, or to 1 decimal place, 176.7 centimeters squared. And that's it. So to find the area of a semicircle, get the area of the whole circle and divide by 2. To find the area of a quarter circle, get the area of the whole circle and divide by 4. If it's a third of a circle, divide by 3. A sixth of a circle, divide by 6, and so on. Okay, let's have a look at our next topic. So our next topic is video 44, which is the area of a parallelogram. So here's a parallelogram, and it's got a base of 11 centimeters and a height of 5 centimeters. And the area of a parallelogram is found by the base times the height. Because if you were to chop this part of the parallelogram off and move it across and put it here, we would now have a rectangle, and the base would still be 11 centimeters because this bit has moved to here, so the base would still be 11, and the height is still 5. So to find the area of a parallelogram, you just do the base times the height. So for this parallelogram, the base is 11, multiplied by the height, and that is the distance between the two parallel lines, which is 5, and 11 times 5 is 55 centimeters squared. If you do have any diagonals labelled, such as this one, you just ignore those because you just need the height. That's it. Okay, let's have a look at our next topic. So the next topic is the area of a trapezium, and this is part of the Corbettmaths revision card. I've actually cut it into little pieces. So you've got the area for a trapezium is given by the formula a half bracket a plus b. So a and b are the two parallel sides of the trapezium. So we're going to add those two together, divide that answer by 2, and then times it by the height, and that will give you the area of a trapezium. So here's a trapezium. So the area would be equal to a half a plus b. They're the two parallel lines, so that's 7 plus 11. And then we'll get that answer, and we'll multiply it by the distance between the parallel lines, which is 5. So when we do that, we get a half, and then 7 plus 11 is equal to 18, so a half of 18 multiplied by 5. A half of 18 is 9, so we've got 9 times 5. That's equal to 45 centimeters squared. And that's it. So to find the area of a trapezium, you add together the two parallel sides, you divide by 2, and then you times by the height, the distance between the two parallel lines, and that's it. And then if you want more practice on that, that's video 48 in Corbettmaths. Okay, our next topic is to find the area of compound shapes. So that's whenever shapes have been put together. Now those shapes could be rectangles, triangles, semicircles, quarter circles, sixth of circles, parallelograms, trapeziums. It could be loads of different shapes, and they've just been put together, and you need to find the area of them. So if you have a look here, we've got this shape. It looks like an arrow, but if we divide it into 2, we can see that there's 2 parallelograms. So we've got 2 parallelograms, and each of them has a length of 35 centimeters for the base, and the height of them, with the distance between the 2 parallel lines, as you can see, the whole thing is 52. When you divide that by 2, we get 26. That means the height of this parallelogram is 26 centimeters, and the height of this parallelogram is 26 centimeters. So all we need to do is work out the area of this parallelogram and the area of this parallelogram, and then add them together. The area of a parallelogram is the base times the height, so that's 35 multiplied by 26. And when we do that, we get 910 centimeters squared. Now these two parallelograms are identical or congruent, so that means that they both have the same area, so it's going to be 910 plus 910, and that's equal to 1820 centimeters squared. And that's it. So to find the area of compound shapes, what you do is you break them down into the smaller shapes, maybe rectangles, triangles, you find the area of each of those and you add them all up, and that's it. Okay, so let's have a look at our next topic. So our next topic is the volume of a prism. So to find the volume of a prism, we find the cross-sectional area. So whenever you've got a prism, it's got that constant cross-section, so it's got that shape that's the same the whole way through it. So for instance, this triangular prism has a triangle as the cross-section, and it's the same the whole way through it. So you get the area of that shape and you multiply it by how long it is. So to find the volume of this triangular prism, we're going to find the area of the triangle at the front and then just multiply it by 4. So to do that, let's work out the area of the triangle. So the area of a triangle is half the base times the height. So the area of this triangle would be half the base, so half times 7 multiplied by the height, 5. So whenever we do that, we get 7 times 5 is 35, and multiplied by half or dividing it by 2 would give us 17.5 meters squared. So the area of this triangle at the front is 17.5 meters squared. Now we just need to multiply by how long the shape is, and the shape is 4 meters long. So if we do 17.5 multiplied by 4, that gives us the volume of this triangular prism. So multiplied by 4 equals 70 meters, and the units would be cubed because it's the volume, so 70 meters cubed. So to find the volume of a prism, you get the area of the cross section and then multiply by how long it is, or alternatively, it's standing upright, you multiply by how tall it is. So if we wanted to find the volume of a cuboid, you'd find the area of the front, multiply by how long it is. If we had a cylinder such as this, you'd find the area of the circle and multiply by how long it is. If it was a cylinder that's standing upright like so, you'd find the area of the circle on the top and multiply by how tall it is, and so on. If you want more practice on volume of a prism, it's video 356 in Corbettmaths. Okay, our next topic. Our next topic is the volume of a cylinder, and as you can see, this cylinder is standing upright, so we're going to find the area of the circle and then multiply by how tall it is. So the area of a circle, area equals pi r squared, so that's equal to pi times the radius. So this is the radius, 8, so pi times 8 squared. And when we do pi times 8 squared, we get that's equal to 201.0619298 and so on centimeters squared. So that's the area of the top. Now we're going to multiply that by how tall it is. Don't round this answer because we're multiplying it by 30. So if you round it, that multiplied by 30 can mean that you're somewhere out from the actual answer. So we're going to take our 201.0619 and so on. If you've got a new calculator display, just leave it there and press multiply by 30. And whenever you do that, you get times by 30, 6,031.857 and so on. And to one decimal place, that would be 6,031.9, and our units would be centimeters cubed. And that's it. So that's how you find the volume of a cylinder. You get the area of the circle and multiply by how long or how tall it is. Okay, so our next topic is Pythagoras, and here's part of the Corbettmaths revision card on Pythagoras' theorem, which is a squared plus b squared equals c squared, where a and b are the two shorter sides, and c is the length of the longest side, with the hypotenuse of the right angle triangle. So here's a right angle triangle, and we've been asked to find x, the length of the hypotenuse of the longest side. So I label the sides first of all, so I label the shorter side a, the next shortest b, and the longest side c. Now in terms of a and b, it doesn't actually matter which way around you label those, as long as a and b are the two shorter sides. And we're going to substitute those values into Pythagoras' theorem. So Pythagoras' theorem is a squared plus b squared equals c squared. So if we substitute these values in, well, instead of a squared, we're going to write 5 squared. Instead of b squared, we're going to write 12 squared. And instead of c squared, we're going to write x squared. So we know that 5 squared plus 12 squared equals x squared. So now we're going to work out 5 squared and 12 squared. So 5 times 5 is 25. And remember, this is a calculator paper, so you can't just write 5 squared plus 12 squared and press equals on your calculator. Plus, and 12 squared is 144, and that equals x squared. Now 25 plus 144 is 169. So that gives us 169 equals x squared. So we've got 169 equals x squared. Now obviously x is the length of the side here, so we can square root both sides. So that gives us square root of 169 equals x, and the square root of 169 on your calculator is 13. So 13 equals x. That means that x equals 13 centimeters, and that's it. So that means that x equals 13 centimeters. Okay, let's have a look at a right angle triangle where we're trying to find the length of one of the shorter sides. So here's a right angle triangle, and again Pythagoras' theorem is a squared plus b squared equals c squared. So let's label our sides. Now we don't actually know which one's the shortest here, so I'm just going to label this side, the x a. I'm going to label the 5 centimeters b, and obviously the longest side will be the hypotenuse, the side opposite the right angle, so that will be c. So we write down Pythagoras' theorem, that's a squared plus b squared equals c squared. And so a squared, that's going to be x squared plus, and instead of b squared, that will be 5 squared, and that equals c squared, which is 8 squared. So x squared, that's x squared plus, I'm working out 5 squared, well 5 times 5 is 25, so that's 25, equals 8 squared, which is 64. Now here we've got x squared plus 25 equals 64. So we want to get the x squared on its own, so let's take away 25 from both sides. So that gives us x squared equals, and 64 take away 25 equals 39. So we've got x squared, and to find x we're going to square root 39. So we'll work out the square root of 39, and that equals 6.244997998 and so on centimeters. So let's round this to 2 decimal places. So that means that x equals 6.24 centimeters. And that's it. So Pythagoras' theorem is really useful for right angle triangles to find the length of missing sides, if you know 2 of them. And Pythagoras' theorem is also useful in situations where you've got shapes that are made up of right angle triangles. So for instance, if there was a rectangle and it's cut across diagonally, you may need to use Pythagoras' theorem to work out the lengths of the sides there and so on. Okay, let's have a look at our next topic. So now we're going to look at our statistics or data handling topics. So we're going to look at Venn diagrams now. And because we're doing M2, we're now looking at Venn diagrams with 3 circles. And that would be 380A in Corbettmaths. So here we've got a Venn diagram question, and it involves 3 circles rather than the 2 that's on M1. And the question says 90 people were asked if they liked 3 drinks. So we've got drink A, drink B, and drink C. And 11 people liked all 3 drinks. So let's put that on the Venn diagram. They like all 3 drinks, so that's going to be 11 people in the middle. 8 people liked drinks A and B, but not C. So they like A and B, so they're going to be in the middle of A and B, so here, but not C, so it's going to be here. 8 people like drinks A and B, so they're in those circles, but they're not in the C circle, so that's there. Next, 17 people like drinks A and C, so A and C would be here but not B, so that means that 17 people will go in there. And 9 people like drinks B and C, so they like drinks B and C but not A, so that means that's going to go there. We're also told that 4 people only like drink B, so only 4 people like drink B. And we're told that 50 people like drink A, so that means that the whole circle here for A will be 50. So if we add up the numbers we know in this circle for A, we've got 17 plus 11, that's 28, plus another 8 is equal to 36. So that means that 14 people must go there. And 3 people did not like any drink, so they're going to go outside. And we've been asked to complete the Venn diagram, so we've done most of it, and there's just one missing number here. Now we're told that 90 people were surveyed, so if we take all these numbers away from 90, we'll see what number must go here. And when we take away all these numbers away from 90, we're left with 24. So that means there must be 24 people in here. And let's just double check our answer, because obviously with a question like this, there's a lot of information. So we're told 11 people like all 3 drinks. Yep, 11 people in the middle. 8 people like drinks A and B, so A and B but not C, so they go there. 17 people like drinks A and C, but not B, so they go there. 9 people like drinks B and C, but not A, so they're going to go there. 4 people like to only drink B, so they go there. 50 people like drink A, and when we add these 4 numbers up together, we do get 50. And 3 people did not like any drink, so they go there, and that's it. So we've completed our Venn diagram. So in M2, or M3 or M4, you may encounter a Venn diagram with 3 circles. Okay, our next topic. Okay, our next topic is to look at the combined mean. So to work out the combined mean, let's just make sure we know what the mean is. So the mean is found by adding up all the values and dividing by the number of values. So that's going to be very useful. And what's also useful is if we know the mean is found by adding up all the numbers and dividing by the number of numbers, if we have the mean and multiply by the number of values, that will give us the grand total. So that's very useful as well. Okay, so our question says, there's 20 students in class A and 10 students in class B, and they sit the same test. The mean test score for class A is 60 and the mean test score for class B is 40, and the question says work out or calculate the mean test score for all 30 students. So we're going to do this question by considering if we know what the mean is for Class A and we know how many students there are, we can find out the total number of marks received by Class A, by the students in Class A. So we know the mean score for Class A is 60 and we know there's 20 students. So if we do 60 times 20, that gives us 1,200. That means there are 1,200 marks obtained by the students in Class A altogether. That's the total number of marks scored. And if we divided that by 20, we get the mean score of 60. So that's the total for Class A. Now let's get the total for Class B. So their class average was 40 and there's 10 students. So if we multiply 40 by 10, that's 400. So that means in total, the 10 students in Class B scored 400 points or 400 marks altogether. So if we add together the 1,200 and the 400, that tells us how many marks were received by all 30 students altogether in this test. So 1,200 plus 400 is 1,600. Now we're trying to work out the mean score for these 30 students. So if we divide the grand total, the 1,600 by 30, we will get the mean test score for these 30 students. So 1,600 divided by 30 is equal to, that'll be 53.33333 so on, or 53.3 reoccurring, or let's just round our answer to two decimal places, so 53.33, and that would be the mean test score to 2 decimal places. And that's it. So whenever we're working out the combined mean, it's very useful to be able to work out the grand total, and that can be found by taking the mean and multiplying it by how many people were involved with that mean, and that will tell you the total, and that will be very useful. And if you want to watch the video on this on Corbettmaths, it's 53A. And just remember, you do have that bumper pack of questions, that M2 practice booklet, which has loads of questions, and there'll be questions on that on the combined mean also. Okay, our next topic. Okay, let's have a look at our next topic. Our next topic is called the estimated mean, and that's video 55 in Corbettmaths. It's one of my favourite topics, and we've been asked to work out an estimate for the mean age. So we've got a group of people, and we know that there's 9 people from 0 up to 10. We've got 13 people from 10 up to 20. We've got 16 people from 20 up to 30, and we've got 2 people from 30 up to 40. And we've been asked to work out the mean age. And remember, to work out the mean age, we add up all the ages and we divide by the number of people. Let's actually start up by finding the number of people, and to do that, so we'll add up 9, 13, 16 and 2, and that's equal to 40. So we know there's 40 people. Now we want to add up their ages and divide by 40, the number of people. But unfortunately, we're not able to do that in this question because we don't actually know all their ages. We've made this group frequency table to make the data a bit more easier to interpret, but unfortunately, we're not going to be able to work out the exact mean. That's why the question says an estimate for the mean age. Okay, so we've got 9 people that have an age from 0 up to 10. We don't actually know their ages. They could be 4, they could be 8, they could all be 9-year-olds. We don't actually know, but what we're going to do is we're going to choose a fair age, or a representative age for these people. Because they're from 0 to 10, we're going to use the midpoint, which is 5 years old. We're going to add a column on called midpoint, and that will be the age that we're going to use for these people. So for the 0 to 10-year-olds, we're going to pretend that they're 5 years old each. We're going to pretend there's 9 5-year-olds. We don't actually know their ages. That's the fairest thing to do. Now we've got 13 people with an age between 10 and 20. So let's pretend they're 15 years old. So let's use the midpoint of 15. And for 20 to 30, the midpoint would be 25. And for 30 to 40, the midpoint would be 35. We're going to imagine there's 9 5-year-olds, there's 13 15-year-olds, there's 16 25-year-olds, and there's 2 to 35-year-olds. That's the best estimate we can do in this situation. So whenever you're doing this estimated mean question, so you'll find the midpoint of each of these groups and you'll make a column for that. So now what we're going to do is, because we're imagining there's 9 5-year-olds, rather than doing 5 plus 5 plus 5 9 times, what we're going to do is we're going to just do 9 times 5. So we're going to do 9 times 5, 13 times 15, 16 times 25, and 2 times 35. So that tells our estimate for the total ages of the 9 people between 0 and 10, the 13 people between 10 and 20, and so on. So we'll call this column fx. And whenever you're doing the estimated mean question, you'll add on a column for midpoint, and you'll add on this fx column, and you'll times the midpoint by the frequencies, and that will tell you your fx column. So 5 times 9, or 9 times 5, is 45. 13 times 15 is 195. 16 times 25 is 400. And 2 times 35 is 70. So we've completed our fx column. Now what we're going to do is we're going to add those up to find our estimate for the grand total. So 45 plus 195 plus 400 plus 70 gives us a total of 710. So our estimate for the total of the ages would be 710. Now what we're going to do is we're going to divide that by the total frequency. So the grand total divided by the total frequency gives us our mean, our estimated mean. So 710 divided by 40 is equal to 17.75. So our estimated mean age is 17.75 years old. And that's it. So to find the estimated mean, you add a column on for the midpoint, you find the midpoint of all the categories, whatever that is, you put the midpoints down, you then multiply those by the frequencies, and that will tell us the fx column, and then you divide the total of the fx column, the grand total or the estimated grand total, and you divide that by the total frequency, and that will be your estimated mean. Sometimes with grouped frequency tables, what we need to do is find the modal class interval. So remember the word modal, it's similar to mode, and that just means the most common class interval. So the most common class interval, well, we just look at the frequencies. So we can see that this category with 16 as the frequency is the most common. So that means that this is our modal class interval. So D is larger than or equal to 20, but less than 30, and that's it. So the modal class interval will be the class interval with the highest frequency. And if you want to recap that in Corbettmaths, it's video 56A. Okay, let's have a look at our next topic. So our next topic is finding the class interval that contains the median. So here we've got a grouped frequency table with duration going from 0 up to 10, from 10 up to 20, 20 up to 30, and from 30 up to 40. And we've got the frequencies and all together. And if we add up these frequencies, there's 40 altogether. And we've been asked to find which class interval contains the median. So if we knew these 40 durations and if we wrote them all out, we're asked which of these categories, from 0 to 10, from 10 to 20, from 20 up to 30, or from 30 up to 40, would the median lie in? Would it be in this category, this category, this category, and this, or this category? Now straight away I can see this is not going to be in the first category because there's 40 altogether. And so because there's 40 altogether, if we divide 40 by 2, that gives us a rough idea as to where the median would be. So 40 divided by 2 is the 20th. So the median would be roughly the 20th value. And because this is group data and we don't actually know the actual numbers, we may as well just use that 20th value. Now strictly speaking, if we knew all the values and we could write them all out in those 40 numbers, we would do 40 plus 1, which is 41. And we would divide that by 2. 41 divided by 2 is equal to the 20.5th value. So if you had 40 people and you lined them all up and we wanted to find the median would really be the 20.5th value. But for grouped frequency tables where you don't actually know the values anyway, where it's just 9 people in between these values, 13 in here and so on, we can just divide this frequency by 2. So that's the 20th and find where the 20th one is. So normally in a question like this, the 20th and the 20.5th value will be in the same category anyway, just to make sure that, you know, whenever they're making the questions that, you know, you don't have a sort of a difference, so that if students went for this value or if students went for the 20th one, they would design the question so they'd be in the same category anyway. And let's just see if that's the case. So here we've got 9 people in the first category. Now we're looking for the 20th one. It's not going to be in there because there's only 9 people there. Now we've got another 13. Well, 9 plus 13 is 22. So up to the end of this category, there's 22 people. That means if you were to line up those people, someone in this category would be the median, or it would be either the 20th or the 20.5th value. And as you can see, that means that both of them would be in this category. So the question says, which class interval contains the median? Well, it's going to be this class interval, 10, which is less than or equal to D, which is less than 20. And that's it. Okay, let's have a look at our next topic. And our next topic is scatter graphs, and they are videos 165 up to 168 on Corbettmaths. Now M1 did have scatter graphs, and you'll notice that if you watch my video on scatter graphs, I plotted the points and we talked generally about what the scatter graph showed us. In M2, we're going to do things like talk about positive correlation, so whenever the points are going upwards, negative correlation, whenever the points are going downwards, and no correlation, whenever the points are all just spread out. Also, we're going to be using our scatter graph and lines of best fit to work out estimates. And let's have a look at some typical questions now. So here's a scatter graph, and it shows the cost of 10 plumbing jobs. So we've got these 10 plumbing jobs, you've got the duration from 0 up to 5 hours and the cost from 0 up to £300, and you've got all the points there. And our first question says, what type of correlation is shown? So because the points are going upwards, in other words, as the hours are going up, the cost is going up, that is a positive correlation, so positive. So if the points were coming downwards in this direction, it would be a negative correlation, and if the points were just scattered around everywhere, that would be no correlation. Okay, our next question. Our next question says, draw a line of best fit. And I've just drawn a line of best fit like so. I've got my ruler and a pencil. I've drawn a line going straight through as many of the points as possible, or as close to the points as possible. This point here is an outlier, so I've just ignored that one. And I've drawn my line of best fit so it's as close to possible to these points. So I've tried to sort of minimize the distance between my line and all the points that I've been given. I normally go for roughly half on either side, but because some are a bit lower down here, I've sort of put it around there. Okay. Now the good thing is with lines of best fit, the examiner has a template that they put over, and they've got sort of a range of areas where you can put your line of best fit. So you don't need to sort of worry too much about it as long as you think it looks good. Okay, so our first question says draw a line of best fit. Done that. Our next question says estimate the cost of a job lasting 2.5 hours. So if we go down to our horizontal axis here for hours, 2.5 hours would be here. And if we get our ruler and pencil, and so use a ruler and pencil whenever you're doing this, and go up to the line of best fit and then go across, you can clearly see that the cost would be £150. So our estimate for the cost of a job lasting 2.5 hours would be £150. Next, the question says, estimate the duration of a job costing £180. So if we go to £180 on the vertical axis here, and we get our ruler and pencil, and we draw across to our line of best fit, and then we draw down, we can see that's 3.5 hours. So the answer would be 3.5 hours. And that's it. Okay, so we've drawn a line of best fit, and we've used that to make some estimations. Okay, let's have a look at the next part. The next part says circle the outlier. So here we've got a scatter graph, and you can see this point just stands out. It just stands out from all the rest, so it's what we call an outlier. Okay, let's have a look at our algebra topics now. So our first algebra topic is expanding brackets, and that's video 13 in Corbettmaths. Now in M2, we've got to be able to expand brackets with a single term outside the bracket. So here's our first example. So our first question says expand x bracket 3x plus 4. So remember, to expand our brackets, we multiply what's inside by the term outside. So we're going to do 3x multiplied by x, and we're going to do 4 multiplied by x. So 3x multiplied by x, well, that would be 3x squared, because we're multiplying the x by x would give us the x squared, and we've got a 3. So 3x multiplied by x is 3x squared. Then we've got our plus sign, and then we've got 4 multiplied by x, so that's just going to be 4x, and that's it. Okay, our next question. So here we've got our term outside, 2y, and we're going to expand our brackets, y minus 3. So we're going to multiply what's inside by the term outside. So we're going to do y multiplied by 2y. Well, that would be 2y squared, because we've got y times y is y squared. And then we've got the 2 as well, so that's 2y squared. Then we've got our minus sign. And then we're going to do 3 multiplied by 2y. Well, 3 times 2y would be 6y. So the answer would be 2y squared minus 6y. And if you want more practice on this, remember you can go to video 13 on Corbettmaths. You can watch that video. Beside that, there's the practice questions and also the textbook exercises. And then also remember there's that bumper booklet of questions, and there'll be questions there that involve expanding brackets. Okay, our next topic. Now we're going to factorize. So we're going to be factorizing these expressions by taking out common factors. And if you want to recap that, that's video 117 on Corbettmaths. So our first question says factorize w squared plus 8w. Now as you can see, both terms have w's, so let's take w out. So w squared divided by w, that would just leave you with w. And then we've got our plus sign. And then 8w divided by w would just be 8. So our answer would be w bracket w plus 8. And you can test it by expanding the brackets. So w times w is w squared, and w times 8 is 8w. Okay, next one. We've been asked to factorize 4y squared plus 6y. So we're looking for common factors of 4y squared and 6y. Now in terms of the numbers, I can see I can divide 4 and 6 by 2. So I'm going to take a 2 out as a common factor. And also in terms of the letters, we've got y squared and y, so we can divide both of those by y. So we're going to factorize this by taking out 2y. So we're going to divide both of these terms by 2y and see what we get. Well, 4y squared divided by 2y, well, that will leave me with 2y, because 2y times 2y is 4y squared. And then plus, and if we had 6y divided by 2y, that would just leave us with 3. So our answer would be 2y bracket 2y plus 3. Okay, our next topic. Okay, we're now going to look at equations, and we're going to deal with equations with letters on both sides. So here's an equation with letters on both sides, and we've got 5x plus 1 equals 3x plus 19. Now, whenever I'm solving equations with letters on both sides, I want to get rid of the lowest number of x's. Now, if you look at this, the lowest number of x's would be the 3x. So I'm going to get rid of this 3x. And remember, we do the inverse to both sides. So if I want to get rid of 3x, I'm going to take away 3x. So minus 3x and minus 3x. So if we had 5x plus 1 and we take away 3x, that leaves us with 2x. We've still got our plus 1. And on the right-hand side of the equation, we had 3x plus 19. We're taking away the 3x's, so that just leaves us with 19. Now this is just an equation like you would see in M1, so we can solve this by taking away 1 and taking away 1. So that would leave us with 2x equals 18. And then we can divide by 2 and divide by 2 and see that x is equal to 9. And again, we can check our answer. 5 times 9 is 45, plus 1 is 46, and 3 times 9 is equal to 27, plus 19 is 46, so that's right. Okay, our next question. So our equation this time says 4x plus 5 equals 20, subtract x. Now whenever I'm solving equations with letters on both sides, I always want to get rid of the lowest number of x's. Now minus x is lower than 4x, so I'm going to get rid of the minus x. Now if I want to get rid of minus x, I'm going to do the opposite, which is add x to both sides of the equation. So I'm going to add an x and add an x. So on the left hand side I had 4x's and I add an x, or one more x, so it's going to be 5x. Plus 5, the numbers will stay the same, equals. And on the right hand side of the equation, I had 20 minus x. I added x, so the minus x and x will add together to give you 0, so they're just going to disappear, so you're just going to be left with 20. So we've got 5x plus 5 equals 20. And this is just like the equations you will have seen in the M1 video. So we're going to minus 5 and minus 5, so that will give us 5x equals 15. And then finally, we're going to divide by 5, and we're going to divide by 5. And that gives us x equals 3, and that's it. So our next topic is forming equations, and that's videos 114 and 115 on Corbettmaths. So here we've got an isosceles triangle, and we've been told the angle at the top is 2x, and we've been told the angle at the bottom left is x plus 20. Now from where the sides of the mark the same, on the left hand side and the right hand side, I can see that this angle is equal to this angle. So this is going to be x plus 20 as well. Now the angles in a triangle add up to 180 degrees. So if we add up all these terms for the angles, the 2x, the x plus 20 and the x plus 20, we'll find that's equal to 180 degrees. So let's do that. So let's take our 2x and add our x plus 20 and add another x plus 20, and that will be equal to 180 degrees. So let's add up our x's. We've got 2x plus x, that's 4x's. And then we've got 20 plus 20, so that's going to be plus 40, and that equals 180. Now we've got 4x plus 40 equals 180, so let's take away 40 and take away 40. So take away 40 and take away 40 leaves us with 4x equals 140. And then we want to get x on its own, so we're going to divide by 4 and divide by 4, and that gives us x equals, and 140 divided by 4 would be 35. If the question asks us to find the size of the angles, then you would substitute the 35 into these expressions. So 2 times x would be 2 times 35. So this angle would be 70. And if we took our 35 and added 20, this angle would be 55 and this angle would be 55. So our angles would be 70, 55 and 55. But the question didn't ask us that, it just asked us to find x, and that's what we've done. Our next topic is to find the midpoint of a line. Now the midpoint of a line, it can be done in two different ways. If it's drawn on a grid for you, sometimes you can do it just by inspection, just by having a look and seeing if you can spot where the midpoint is. So here we've got the line AB, and if I wanted to find the midpoint of this line, I can see straight away it's here. So that means that the coordinates of the midpoint would be 1 minus 2, because it's 1 across, 2 down, so it's 1 minus 2. So that would be the midpoint of the line. So if you've got it on a grid, you can just sometimes spot it, but sometimes you're given the coordinates. So the coordinates of B would be the point 3, 0. The coordinates of the point A here would be minus 1, minus 4, minus 1, minus 4. And if you were given the coordinates and you were asked to find the midpoint, what you do is just add the coordinates together and then divide by 2, and that will tell you the coordinates of the midpoint. So if we have minus 1 and 3, well, minus 1 plus 3 is 2, and divide by 2 is 1, so fantastic. And then in terms of the y coordinate, if we add the y coordinates together, the minus 4 and 0, well, minus 4 plus 0 is minus 4, divided by 2 is minus 2. So if you add the coordinates together and divide by 2, you'll find the coordinates of the midpoint. Okay, our next topic. Okay, our next topic is to find the length of a line. Now if you have a look at this line, you can see if we just go across and then go up, we can turn it into a right angle triangle. And the great thing is then we can use Pythagoras' theorem to find the length of this line. So this is a right angle triangle. So let's mark on our lengths. So we've got this point here, which is the point 1, 1. In terms of horizontal, you can see we're going across 1, 2, 3. So it's going to be 3. And in terms of the heights, you can see here we're at 1 and we're going up to 5. So that means the height of this triangle would be 1, 2, 3, 4. So we've got the lengths 3 and 4. Now they're not centimeters, they're just 3 and 4 units. And we want to find the length of the line. So remember, Pythagoras' theorem is a squared plus b squared equals c squared, where a and b are the shorter sides and c is the longest side. So a and b, well, so a is going to be 3, so 3 squared plus, and b, let's let b equal 4, so 4 squared equals, and then we've got c squared, well, that's going to be ab, so we could call it x if we wanted to and just write x squared. Then let's work out 3 squared plus 4 squared. Well, 3 squared is 9, so we've got 9 plus, and 4 squared is 16, so 16 equals x squared. So we've just squared 3 and squared 4. Then we're going to add our 9 and 16 together, so 9 plus 16 is 25, and that equals x squared. So we've got 25 equals x squared, or x squared equals 25. Now we want to find the length of this line, so what we're going to do is we're going to square root the opposite of square root to find the length of this line. So we're going to do the square root of 25, and the square root of 25 is 5. So that means that the length of this line is 5 units. And that's it. So to find the length of a line, you can just use Pythagoras' theorem. If in the question, instead of giving you a grid, they've just given you the coordinates, what you can do is you can do a little sketch. So here, if you had the coordinates 1, 1, and the coordinates for B were 4, 5, what you can do is just do a little sketch and sketch where those coordinates would be 1, 1 and 4, 5, and say, well, if you're going from 1 across to 4, that's 3, and going from a height of 1 up to 5, that's 4, and then you can do your right angle triangle and then do Pythagoras on it. Okay, and our next topic. Our next topic is to work out the gradient, or the steepness of a line. So to work out how steep a line is, we use the formula gradient equals rise over run. So if we've got a straight line drawn on a grid, if we do the rise of the line divided by the run of the line, that will tell us the gradient or the steepness of the line. And this is video 189 on Corbettmaths. So let's have a look and see what rise and run are. So if you've been given a line drawn on a grid such as this one, and you've been asked to work out the gradient of it, choose 2 points on the line to begin with. Now in terms of the points here, we could choose this point here, -1, -2, or 0, 0, or 1, 2, or 2, 4, or 3, 6, or 4, 8. They would be good points to choose. I'm just going to choose this one here, 1, 2, and I'm going to choose this point here, 3, 6. And I'm going to turn it into a little right angle triangle. So I'm going to go across, and then I'm going to go up. So the rise is the rise here, so it's how far up you've gone. So whenever you draw your little right angle triangle, it's the rise, it's how much the line's gone up by. So if you can see, we've gone up, and make sure you know what you're going up in. So we've gone up in ones here, so we got by 1, 2, 3, 4. So the rise here would be 4, and the run, and again check what we're going to cross in, we're going to cross in ones, so the run would be, well, we're going to cross 1, 2, so the run would be 2. So we've got our rise of 4, and we've got a run of 2, so let's work out the gradient. The gradient is the rise, 4, divided by the run, 2, and that's equal to 2. So the gradient of this line is 2, and what that means is for every 1 unit you go across, the line's gone up 2. And as you see, if we started at 0, 0, if we go across 1, it goes up 2. If you go across another 1 to 2, you go up another 2. If you go across another 1 to 3, you go up another 2, and so on. So the gradient of this line is 2, and the gradient is found by doing the rise divided by the run. And you just draw a little right angle triangle, you just work out what the run would be and the rise would be, and then you do the rise divided by the run. So if you had a line going downwards like this, and you wanted to find the gradient of this line, again, you would draw a right angle triangle, you would choose 2 points. So I'm going to choose this point, and I'm going to choose this point. And as you can see, we're going across 1, so going from 5 to 6, our run is 1. And in terms of our rise, well, we're going downwards this time, so our rise is -4 because we're going down. And you would do -4, the rise, divided by 1, and that would be -4. And that means for every 1 you go across, the line goes down 4. If you go across 1, it goes down 4, and so on. Okay, let's have a look at another gradient question. This time I've changed the scales, so the numbers are a bit bigger, and we've been asked to work out the gradient of this line. So here we've got a line, and we're going to choose 2 points on it. I'm going to choose this point, which is the point 0, 50. I'm going to choose another point, and another point I think looks quite good would be 25, 250 here. And let's draw our little right angle triangle. So we're going to go across, and then we're going to go up. Now in terms of the run, we're going from 0 here, all the way across to 25. So the run here would be 25. We're going across 25. And the rise, well, we're going from here up to here. So we're going from 50 up to 250. So our rise would be 200. And then to find the gradient, we're going to do the rise divided by the run. So we're going to do the rise, 200, divided by 25, and that's equal to 8. So the gradient of this line is 8. And that what that means is for every 1 you go across, 1 unit you go across, you're going to be going up 8. So the gradient of this line would be 8. Okay, our next topic is real life graphs, and real life graphs was on M1, but this time we're going to be using the gradient and the y-intercept in this as well. So here we've got an example, and the question says the graph below shows the cost of hiring a hot tub, and this is video 171A in Corbettmaths. So here we've got a graph that shows us the cost of hiring a hot tub, and you've got the number of days going along horizontally, and we've got the cost going up vertically, so going from 0 up to 350. So the question says the graph intersects the vertical axis at 100. So as you can see here, it starts at 100. What does this represent? So as you can see here, this would be on 0 days. So this is like a set fee. It's like a set charge that you're charged for hiring the hot tub. So no matter what, there's £100 to begin with, and then you're going to be charged so much per day. So what this represents, so this represents a fixed fee, a fixed cost of £100. So that means that no matter how long you hire this hot tub for, there's a £100 fee to begin with. If this was the cost of a plumber, that might be a call-out fee. Or if this is a taxi, that whenever you go into a taxi, sometimes you see the meter starts at a particular number, like a set fee that you have to pay to begin with. So this is a fixed cost, this value of £100. The next question says, find the gradient of the graph. So we've got this graph and we want to find its gradient. So let's choose 2 points. I'm going to choose the point here, 0, 100. I'm going to choose this point up here, which is 10, 350. And let's make our little right angle triangle. So going across and going up. And let's work out the rise divided by the runs. So our gradient, m, that's the letter for gradient, m, is rise divided by run. So for our right angle triangle, the rise, well, it's gone from 100 up to 350. So that's a rise of 250. So that will be 250 divided by. And the run, if you look at how much we've gone across by, we've gone from 0 to 10. So the run would be 10. So we're going to do 250 divided by 10, and that's equal to 25. So that means the gradient of this line is equal to 25. And the question says, explain what the gradient represents. So remember the gradient, it means for every one you go across, how much the line goes up by. Now in terms of this context of hiring a hot tub, what that would mean is for every one more day you hire the hot tub, how much the price increases by. So that's what it means. It means the hot tub, it means the cost per day of hiring the hot tub is £25. So that'd be the cost per day, £25. Okay, and that's it. So in this video, we've gone through all the M2 topics. Remember, these topics will be very useful if you're studying for M2. Remember to revise the M1 topics as well and watch that revision video as well. If you're studying for M3, the M2 topics will be very important. Even M4, the M2 topics will be very useful as well. So it's very important that you know these topics. And in this video, I've spent 2 or 3 minutes going through each of them to make sure you're familiar with these topics. If you do need extra help on each of the topics, remember there you have got the video numbers where you can get maybe a 10-15 minute video on each of those topics. And if you do want to do some extra practice, there was that booklet, this booklet, where you could do questions on each of the topics as I went through the video. So you may have watched this video, paused it, made some notes and then tried the questions. That would be a fantastic way to watch the video, and hopefully that booklet will be useful as well. And just remember, in this video I've used several of the Corbettmaths revision cards as we've gone through the topic, and those foundation revision cards will be really useful for students studying for M1 and M2, even M5 and M6 as well. Also remember, there's the 5-a-days, and if you're studying for M2, I'd highly recommend you look at the foundation 5-a-days and even have a look at some of the foundation plus 5-a-days. It'll have some good Pythagoras questions in there as well. And that's it. So I really hope you found this video useful. It's been a long video. I hope you haven't watched it all in one go. I hope you've written some notes and done those questions on it. Please like this video. Please subscribe to the Corbettmaths YouTube channel, and thank you so much. Good luck with your studies.